I'll explain it in a journey. So what happened is in the first year when I was selected in aerodynamics team, our car had a very low profile aerodynamics, like just the side pods and just the nose cone. So everything about aerodynamics was just those two things: the nose cone, the side pods. That's it. That's aerodynamics in the first year when I joined. So what happened is I started taking interest into what had been into other teams. In the first event itself of FSI 16, I had seen Pravega Racing, I had seen Orion Racing, and they had some really good aero kits during that time. So the thing with me was that why can't we make such aerodynamic kits? Why can't we go into the space that they are doing? Our college will be supporting us. We can like take a lot of research and do a lot of manufacturing as well, because everything that we used to do was in-house from the start. We didn't go to a lot of outside vendors because our college has a lot of manufacturing facility. So because of it, we had to start, but there was no option as such given from the team side at during that time. So the first thing that I started with was making a aero kit, designing the aero kit, and also the part that came after that was manufacturing. So during that time when I started, we were working on FRP. Yeah. So we didn't have carbon fiber when we started with in my first year. So FRP, as you know, was not the best option to have a aero kit with. But
Exactly.
still, like I had the passion to shift this FRP to carbon fiber right after the first event, because if other teams could do it, why not us? Or why not any other team in Formula Student? So it bite me at that time, and then I started working on that thing. So the second car in which I was involved in had a full aero kit. That was the car's name was Falcon, and the event was FB17, the first Formula Bharat that was. So during that time, we had the full aero kit. We had the front wing, we had the rear wing, we had the side pods. We didn't have a diffuser at that time, but apart from that, the aero kit was full. And that car had cleared technical inspection in the first round itself with the full aero kit. So we were the first car in that event to complete the technical inspection first. And the car overall did a good performance. Something happened in the event is that our wing, because of the low ground clearance, it hit the floor and the wing got detached. So during that time, we had to take a decision of not use the front wing for the endurance. We removed it, and during the endurance, if you see the pics of Team Octane Racing, you'll see that just there is a rear wing on the car, which actually didn't help us much. But the car was looking great on the endurance. It completed the endurance with the wing, and that gained a lot of traction in the Formula Student community. And I've heard a lot of comments that that car was one of the best looking cars that we had in the event that time in FB17. And it so happened after that that I started gaining interest into the manufacturing side, because my degree was production engineering. I, I did my BTech in production engineering in COAP. So the interest went more from designing the part to manufacturing the part. So during that time, I still like I have done a lot of CFD. I have done a lot of design things into the team. But then the thing is that the manufacturing part of carbon fiber was challenging, and that is where I wanted to enter. And what we developed, we still have the in-house product that we developed, and it was a low-cost setup for manufacturing composites. The whole thing with composites is, and carbon fiber in general, is that it has made a hype of being expensive. It has made a hype of being very difficult to manufacture. It needs a lot of expertise. The expertise is true. The experience that you have with the fabric is required. But then the hype that has been created about it is not very true. And we got to know that in the second year when I actually we introduced carbon fiber in the team. The team was not very happy with the decision because of the investment that was going in. But then, as the parts came in, as the parts started reducing weight of the car, the whole thing went into place. And once we got the carbon fiber into the team, now there is no going back. Now there is no going back to FRP or any other metal or plastic fabrication that we were using. So in my second year, we started manufacturing the carbon fiber parts. Then after that, we started improving. We made our own custom impact attenuator. which was from carbon fiber, and that won us the most innovative team award at
Yeah.
Supra. So
Supra.
that was the main part. We actually have a research paper going on the same, and apart from that, we did the testing of it. Everything was done with the impact attenuator. So that was a very big challenge for us actually in terms of composites, because it's a very difficult part to manufacture. The body panels, the
Okay.
aero kit, and all is manufactured by most of the people, but
Mm.
manufacturing a structural part for the car using composite
Mm.
was a challenge, and that was done by our composite team when I was the head. After that, my vision into the goal was to have a monocoque, of course, but the
Mm.
monocoque thing is a bit difficult in the Formula Student
Mm.
community to manufacture. There's a lot of investment required, there's a lot of team expertise, and the whole team bonding together is required in order to do that.
Mm.
So, the thing we started with was a floor, carbon fiber floor for the car with no members.
Mm.
Also, a tub seat. With that, there was a advance in the composite steam as well. We didn't have a firewall. We were
Okay.
on a KTM 390 engine with a turbocharger, and we had a carbon fiber seat, but we didn't have a firewall. Our seat was the firewall. And we
Okay.
have cleared our TI with
Mm.
this kind of a setup at Formula Bharat as well as Supra. So the car that
But
ran in Supra, there was no firewall on the
mm.
car. So
So it did
we have
manage
reduced.
to go without a firewall.
Yes, yes. And we had done it successfully. We had a lot of setting go in place. We had a lot of testing with the seat. The seat itself was the firewall. There was no firewall required.
Okay.
So the seat was the
Mm.
firewall. And that's what the maximum weight reduction was. Apart from that, the floors that we made were carbon fiber. Right now in
Mm.
the car, there is no structural member below the seat. So it's just the seat, then the carbon fiber panel, and nothing else. So there's a lot of weight reduction that happened with that.
Mm.
And then we started going it into more of composites thing, making lighter like the process. We optimized the process of manufacturing carbon fiber actually. We started with
Mm.
just hand layup, then we went into
Oh.
vacuum bagging, and right now the
Mm.
team is on infusion. And
Okay.
we have
Okay.
also tried
Mm.
autoclaves. We have also tried a lot of other manufacturing processes. So, and all these things have been done in the lab itself. We have our dedicated composites lab in the team section, and that is where a lot of work with the composites happens. And we have dedicated a team of 3 to 5, which was started during my time when I was the
Mm.
composites team, and that has helped a lot in the weight reduction of the car. So many of the things started reducing weight due to the composite team. So that was the journey actually from aerodynamics to composites. Now, along with the
Okay.
composites, when I was not manufacturing the parts for the composites, once the composite
Mm.
part is done and it's set on the car, like the chassis, it's done with the, we are done with the
Mm.
part. So there was a lot of
Mm.
free time that I was getting in the team, not free as such, but time to spend on something else. During that time, I
Mm.
focused my thing on sponsorship. And in
Mm.
sponsorship, I started taking meetings with sponsors. I started meeting, we
Mm.
started going in. So that's when I got to know about the finance of the team. How is the team running on? What kind of finance is getting in, and all those things. There were two types of things that I was being able to handle. And then naturally, it came to that I had to get into the driver as well, the driver part. So in the third year itself, I started testing,
Mm.
and we did the testing with me, but I wasn't the first driver choice. I was a to call a backup driver for the team, as you require two
Okay.
drivers for
Mm.
Supra
Two
and four
drivers.
drivers for
Got it.
Formula Bharat. So I was on the
Mm.
third or fourth position as the driver, and because of that I got to know a lot about the car in general, not just the subsystem that
Mm.
I have been handling, but about the whole car, all small nooks of the car. And that was a decision of the team afterwards to have me as the captain, and which came in the fourth year. And during the time of the captaincy, I was still doing the sponsorship and the driving for the event, and that's how it happened. Like experience in the carbon fiber thing, and low cost manufacturing actually. Our products
Mm.
that were made and the parts that were made, if you compare with other teams or stuff, we have one of the lowest manufacturing costs in the Formula Student, and that actually helped us in the cost event in FB 19 where we came second. So that was one of the points. And after that, I have done a carbon fiber pod for Team Avishkar. So
Hmm.
the pod of the team, the carbon fiber pod, was manufactured by me. So that
Okay.
experience helped me into the manufacturing of that pod. That was the first Indian carbon fiber pod for a Hyperloop team, because it was the
Hmm.
first Indian team to go to
Hmm.
the.
To go
So
to,
it
yeah,
helped
yeah,
a
yeah.
lot. It helped me a lot in that way. The experience that I gained in the composite field was immense through the team, because we started from scratch. No one taught us
Hmm.
anything.
Hmm.
No one was actually also helping us in that way. We were on our own, learning it by experience, making mistakes, and then coming up with new ideas.
Hmm.
So that was the whole thing.
So you guys really achieved something that many teams just dream of. We still
Actually, but
don't.
it
We still,
requires a team.
yeah.
It requires a team, and it requires a vision. So in terms of the composites lab, what we used to do before was working on composites along with the team. So we
Hmm.
started
Hmm.
with working on composites inside the team where the car was made. But that's not a very good
Hmm.
thing to do, as working on
Exactly.
composites is not good for health, first of all, if you're doing
Hmm.
it openly. And secondly, it might affect the welding, because there is a lot of
Hmm.
fumes that go into the air during the composite, the resin testing and all those things. So it's not very useful during the welding. It might hamper the welding processes or any other
Hmm.
electronics thing that is going on in the lab. So first thing
Hmm.
was that we had to separate the lab. So
Hmm.
separating the lab gave us our own space of testing the composite parts, whatever we want to make. And we had a discussion with the college as well that we want a clean room for the
Hmm.
composite manufacturing. So according to them, we got the permission. We got the. It was small. It was not very big. Like the team part was 100, and the part that we had got for composite testing were 15 or 20. So that was the
Okay.
thing. So it was not very
Hmm.
big, but it was a dedicated setup for it. So everyone
Hmm.
who's going in was doing the work on the composite, nothing else. So that's how it started gaining traction. And in start, we were just two people in composites when we got the carbon fiber thing. Me and my senior Alok, who right
Hmm.
now has completed his masters in motorsports engineering from Cranfield,
Okay.
and
Hmm.
his vision is to get into Formula One, and I
Hmm.
surely think he will. Right now, he's got a job in UK. I won't disclose the name of the company, but he is working
Yeah, yeah.
in automotive.
Hmm.
So
Hmm.
we were the two who had the vision to get the carbon fiber in the team, and we did it with two people itself. We tested vacuum bagging, we tested
Hmm.
resin infusion, and after that we started growing the team for composite. So when I was in the team in the captain's time, we had six people in the composites team. Six people dedicatedly working on the composites team, and some of them also
Hmm.
working in the chassis section.
Okay, okay,
So
okay.
we had divided the composites team itself into structural and non-structural. So the structural one
Hmm.
is working on the structural parts of the car, like the impact alternator floor, visuals, steering
Hmm.
columns, and all those things. And the non-structural is working completely on the aerodynamics. So we had integrated the aerodynamics team into the composites team. There was no need of a extra aerodynamics team because everything working on aerodynamics had to go through composites.
Exactly.
So that is why we merged the team and the team became bigger that way. So
Okay.
the person who was doing the aerodynamics was got up into the composites team, and there were six people working on the team because the number of parts now on the car were a lot, and that required
Hmm.
a year-long testing and a year-long manufacturing. So
Hmm.
because of that, the team started growing. And in the future, when the monocoque things come, the team will
Hmm.
have to grow. The team will have to grow to a size of 10 to 12 people because the chassis
Okay.
teams gets into the composites team then.
Hmm.
That's what
Hmm.
happens.
Hmm.
So there is a merger of the chassis and composites team, structural team, aerodynamics team, aesthetics team. They have
Hmm.
to collaborate a lot with the composites team. So we did it in the other way. Rather than splitting up the teams into small, small things, rather make a big
Hmm.
composite team and they are working inside on all those things related to composites. So that was the thing.
Okay. Hmm.
We actually didn't have a mentor for composites, as I mentioned before. There was no
Hmm.
like we had a composites lab in the college, but that was not
Hmm.
very active. We had a
Okay.
faculty advisor who has done his PhD in composites, but in
Hmm.
terms of what we were doing and what we were trying to do, it was uh, meant for small scale manufacturing or prototyping.
Hmm.
And
Okay.
our faculty and everyone who has worked in composites, they have a lot of experience in mass manufacturing or even manufacturing for big clients. So that it's not
Mm,
very helpful directly for small scale manufacturing or prototyping.
mm,
It's a completely different thing
mm,
that you have to keep trying on. So prototyping is all about
mm,
trying and failing. So
mm,
in that time, what we did is we got a lot of carbon fiber sample, and we had kept around 25% of the sample just for testing. We even do that now. Whatever we
mm.
call a lot of things for just for testing, because mistakes do happen in composites, and once the mistake
Yes.
happens, it's irreversible. The process itself is irreversible. The parts goes waste. So rather than
Mm,
having the main part go waste, imagine a full
mm,
body panel not being cured properly. That's not the thing that you
mm,
want when you are doing. That's a lot of investment going in, and it might not be the right thing to do. So rather test first, get the confidence that now the part is ready to make, the thing that you have
mm.
done, the type of strategy that you have used for the composite, and then only go for manufacturing uh, the main part, so that
Okay.
the losses are reduced and your team gets a lot of knowledge of what to do now because of the testing. You might be testing a lot of fabrics, you might be testing a lot of resins, a lot of
Mm,
manufacturing techniques, temperatures,
mm,
various environments. All those things matter, and it matters a lot. And we
mm,
got to know this hard by actually having one of our nose cones not cured in rainy season, and that is a very big problem that happens with composites. The
mm,
humidity creates a lot of problem during curing, and it was
mm,
our first time, so we didn't have a lot of experience, and it just happened. But that has taught a lot to the team now, that
mm.
all the manufacturing should be shifted from the rainy season to the dry seasons. The more drier weather it is, the more better it is for manufacturing.
Okay. So rather than keeping the research theoretical, it was
Yeah,
a trial and
rather
error.
than theoretical, we based our thing on theory, but the
Mm,
theory was just the start. It was just the
mm,
start. The theory won't tell you anything about composites. The things written in
mm,
theory
mm.
are very different from what you are going to encounter in
Exactly.
field. So
Mm,
I myself might have made around 1,000 parts in carbon
mm,
fiber. I used to bring the parts at home. I used to keep trying on them, and
mm,
then I used to take the cured part to the lab in order to test, in order to bend test, check for
mm,
cooking and all those things. But that is what is required. If you're not
mm.
trying at that level, then I don't think there is a lot of help that you will get from the composites team. Or
Exactly.
composites might be like uh, carbon fiber is a very vague term. Okay, you
Yeah,
might be
very,
using
very much
carbon
so.
fiber for just aesthetics. That doesn't make sense.
Mm, mm,
Using composites in the team means you have to do it for performance. If you are not
mm,
focusing it on performance, there is no point of using carbon fiber. You can get the carbon fiber look by vinyling or any other thing. There's no need of
exactly.
actually getting into carbon fiber unless and until you
Mm,
have tested all those things, or in my term, you have got your hands dirty. That's the main thing
mm.
for composites. If you
True,
don't get
true.
your hands dirty, you won't know what is going on.
Mm,
So that is
yeah.
the thing for composites. And I spent half of the time in my team for composites. I was known in the team for or in the college for composites. So people from the other teams, the FE cycle team, the Baha team, and all other
Mm,
teams that we had in our college, even we have a Hyperloop team. So because
mm,
I had done it from scratch, there was a lot of teams that I was helping in terms of consultancy, as you call it,
mm,
in terms of telling what kind of things you should be doing. And it helped me
mm.
gaining the IIT Madras project as well, and they were very happy with the product.
Mhm.